Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining Layer 2 loops. When deploying a network, it's extremely important to ensure your physical connectivity is done in such a way so that you avoid any Layer 2 loops. Layer 2 loops can be devastating to a network, and if left unchecked, can cause a whole network segment to fail. What is a Layer 2 loop? Well, if we assume that these switches here are all configured to operate on VLAN 1, as is their default configuration, by connecting the switches together in this fashion, we get a Layer 2 loop. That is, a physical loop through which Layer 2 communication takes place all the way through. There's no router or Layer 3 device here interrupting the flow. Now, this setup is problematic. Why? Switches are designed to flood frames on all their ports when there's no matching MAC address in their MAC address table. We've already seen that in a previous video in this series. So if there's a loop like this, for any communication from host A to host B, this frame here will have a destination MAC address of BBBB. Now, assuming this is the first communication on the network, the MAC address table of the switches will be empty, as you can see here. That means that this frame will enter switch 1, no match will be found in the table, and the switch will flood the frame out of all ports. The other switches will also receive this frame, and assuming they too don't have an entry in their MAC address tables for BBBB, the frame will enter switch 2 here and will be flooded. Switch 3 will do the same, and the frames will be retransmitted to switch 1, which will flood them out again, and so on, resulting in endless Layer 2 frames traversing this physical loop. The switches will eventually become overwhelmed, their interface buffers will fill up, and frames will be dropped. Any other traffic, including traffic that's not being flooded, will also suffer. This flooding and reflooding is what is known as a broadcast storm. Even though these are not broadcast frames, the term broadcast storm is still used simply because when the destination MAC isn't in the MAC address table, they are broadcast out of all ports. Now, this example assumes VLAN 1 on all ports, but a similar behavior will be seen on topologies that have additional VLANs, resulting in logical loops, which are limited to those specific VLANs. If we have this arrangement here, you can see that VLAN 33, which is also transmitted across these trunks, has created a Layer 2 loop, which will cause the same disruption. But such a broadcast storm would be limited only to VLAN 33. This trunk here doesn't have VLAN 33 included, so the extent of the broadcast storm will not impact this link or this switch here, which serves other VLANs. Now, other VLANs that may be configured on switches 1, 2, and 3 will not be impacted directly. So if these switches have other VLANs such as VLAN 10, 20, and 50, they would not experience a broadcast storm. However, these switches have been impacted on their resources, such as the buffers on the physical interfaces, CPU processing, as well as memory. So any other VLANs configured on the switch will be indirectly impacted simply because the switch resources will be taxed and those other VLANs will not be served appropriately. Now, some of you will probably be thinking at this point, we have spanning tree protocol, which resolves this, and yes, that is true. But I wanted to first illustrate the problem so that we can understand how it is resolved by STP. So we're assuming here that spanning tree protocol is not functioning in any of these scenarios. Now, a larger network like this one may have the potential for many Layer 2 loops. You can see that here, and here, and here, and in other places as well. Now, ideally, in order to avoid such physical Layer 2 loops, one approach would be to design your network like a topological tree. In other words, make sure that the connections between switches are such that no physical Layer 2 loop can be created. The result is a physical tree with a root and branches that never reconnect to each other. And that's perfectly fine, and it is a valid solution. The creation of this tree-like structure by moving from a topology like this to a topology like this has a specific name. And guess what it's called? It's called a spanning tree. The spanning tree is something that's used in disciplines like mathematics and logic. So it's not limited to just networking. And actually, it comes from a mathematical discipline called graphing theory. But we'll talk about that in another video. So this is a physical topological approach to eliminating layer 2 loops. However, this solution has several inherent drawbacks. First of all, it's not always convenient to cable a network in this way. Switches are not typically spaced out nicely like this. They exist in telecom closets with various difficult cable paths that don't always make this arrangement easy. And secondly, and probably most importantly, this setup has many single points of failure. If this link here fails, you lose the whole of this part of the network. The same happens if this link fails or if this link fails. Although this resolves the layer 2 looping issue, we have a very significant problem with redundancy, which is especially important in larger networks. The solution to this is to physically create layer 2 loops, ensuring redundancy and eliminating single points of failure in the network infrastructure, while at the same time logically maintaining a loop-free tree structure. And that's exactly what Spanning Tree Protocol, or STP, does. It allows us to physically create multiple layer 2 loops in our topology to resolve the redundancy issue, while dynamically and logically blocking specific ports on the topology to ensure that you maintain the logical spanning tree structure. Now, if you're not that familiar with STP, not to worry, my next video dives deep into that. But for now, let me just say that STP does this on a per VLAN basis as well. If a link fails, such as this one, STP will automatically reevaluate the tree and unblock the appropriate ports to resume connectivity. Now, in order for this to be successful, you will require all switches to support spanning tree and to support the same version of spanning tree protocol, because there are indeed different versions. If they don't, then there is a danger of STP failing or misbehaving, resulting in unpredictable layer 2 behavior. For example, I remember in a particular installation many years ago where I was involved, the network went down and we were at a loss to discover why, until I discovered that someone had plugged in a small 5-port switch into the network jack and then connected that to another 5-port switch, which in turn connected to another network jack. And those two network jacks, of course, connected to the main switch for the floor in the telecom closet. That main switch supported STP, but guess what? Those 5-port switches did not support STP. So a layer 2 loop was created, which resulted in a broadcast storm, which resulted in the whole VLAN just failing to communicate. Now, Spanning Tree Protocol is enabled by default on most modern network switches, whether managed or unmanaged, and you shouldn't have to worry about making it work in simple topologies. But as your topologies become more complex, the way that STP interacts with other features and with your topology becomes important, and that's why STP must be configured intentionally. STP is not a trivial protocol, but has many permutations and must be configured appropriately, especially for larger topologies. You must appropriately choose which switch will act as the root bridge. And you must also take into account the use of multiple VLANs, and you must also ensure that STP will reconverge very quickly in case of a failure. In the next video, we'll talk about STP, how it works, and how it should be configured in general, as well as some information about the various STP versions. But for now, that's it for Layer 2 loops. If you like my teaching style so far and these are topics that you're interested in, check out my Mastering VLANs and Trunking course on my website. It goes into much more detail than this YouTube playlist and includes hands-on labs, configurations, PDF notes, quizzes, and a final exam, all of which will help you to master the concepts of Layer 2 switching. Check it out now at my website at www.telecomtech.io. You can click on the link in the description below as well. There are more courses on additional topics coming up soon. Check it out and join my newsletter to be the first to know about new content, along with some exclusive offers along the way. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.